In this OGE, we learn the chain rule. Chain rule has two different versions. So let's learn the first version here. So we use the chain rule to differentiate composite functions. So if you have a composite function, we can use the chain rule to differentiate that. So what is the composite function? So when you have a function y, which is f circle g, we know that we can write this function as f of gx. So when you write it like that, there are two types of functions. There's a one function, what we call the outer function. That's the outer function. And then we have another function, what we call the inner function. So we have two different functions. So the first goal is to figure out what are those two functions. What is the outer function? What is the inner function? So after that, what we're gonna do, we're gonna say let u equal the inner function. With u equal the inner function, then if you call the inner function as u, then you can see that the outer function you can write as fu, because you consider the inner function as u. So you consider the gx as u. So if you replace gx by u, you can write the other function as fu. So that's the first step. And then what we can do is we can write y equal fu. So you can rewrite the original function as a function of u now, where u is the inner function, in this case gx. So that's the first step to use the chain rule. So you're going to figure out what is the inner function and then what is the outer function. Now after you figure out these two, then we can write the formula. This is what we normally call the Leibniz formula. So the Leibniz form, what the Leibniz form says that, so you're going to say dy over dx. So what you're going to do, you're going to differentiate the original function with respect to the original variable, which is x in this case. So what it says that this equals to, you're going to differentiate the original function with respect to u now. So the form of u is simple than the original one. It will be clear when we do problems. And then multiplies by derivative of the inner function. So this is the form of the Leibniz rule. So you can see how we remember this one. You can see there's a kind of way to remember. You can see you have du and du, so that it looks like they cancel each other, but that doesn't happen. But it looks like, because d by du is an operator, so you can cancel. And then what happened here is, and you can see, so the first part is the you're gonna differentiate the outer function with respect to u, and then you're going to differentiate the inner function with respect to x. So you can see, first one you differentiate with respect to u, and the second one you differentiate with respect to x. So now let's look at this using an example. So let's say we have the question differentiate y equal square root x cube plus 1. So one thing you can notice is that this is not like a basic function. So that means you cannot use the power rule here. You cannot use the power rule directly. So what we can do, as we discussed, we can identify the inner and outer functions. So we have y equal x3 plus 1 square root. So what we do, we're going to pick the inside function as u. So when you do that, and you can see, you can rewrite your function with respect to u now. Using u now, it is simply square root u. If you put u as the inside function, and you can see that it is square root u. So we can identify the two functions now. So we have y equal square root u. We can rewrite as u to the 1/2 for future. It would be easier that way. And then we know that what's the inner function, which is u equal, inner function is x3 plus 1. So that's the first step. You're going to figure out what is the outer function and what is the inner function. Now what we're going to do, we need to take the derivatives. The first one, we take the derivative with respect to u. So that means we can just use the power rule here. So the power rule is, we know that if you want to take the derivative of x to the n, it is simply n x to the n minus 1. That's the power rule. So we can use this here. So in this case, the power is 1/2. So it is 1/2 u to the, you subtract 1 from the given power. So that means you're going to get 1/2 u to the negative 1/2. So that is the derivative of the outer function with respect to u. Then what we can do, we can take the derivative of the inside function with respect to x. So we get the derivative with respect to x, which is 3x squared plus 0, because it's a constant, again using the power rule, so which is simply equals to 3x squared. So we found two derivatives. First one with respect to u, second one with respect to x. Now what we're going to do, we're going to plug into the formula. So the formula says dy over dx equals dy over du times du over dx. So it is always a good idea to always write this formula when you do problems, then you don't make mistakes. So first one, we know that the first one we already found it, which is simply 1/2 u negative 1/2 times the second one is 3x squared. So that is the derivative. But we are not going to leave it like that, because you can see there's a u in there. You have to write the final answer only in terms of x. So what we can do, we're going to first we can rewrite this one as 2. 1/2 is square root, so the 2 square root u times 3x squared. And then what we can do is we can plug in to the u, because we know that u equal x3 plus 1. So that means you can write the final answer as 3x squared divided by 2 times square root. We plug in for u, which is x3 plus 1. So that is the final answer. So if you need more practice, you can look at the practice problems video, which solves at about 10 problems of different difficulties. And also, if you need to know more theories about that, and you can look at the main video about chain rule. So you can also find all of them in the description. So thank you.